We all use AI pretty much every day now, right? But behind every single chat, every image you generate, there's this hidden cost. Today, we're going to pull back the curtain on the massive environmental footprint of AI, specifically its incredible thirst for energy and water. And trust me, the numbers are pretty shocking.
And if you want to talk about scale, just listen to this quote from the former CEO of Google, Eric Schmidt. He's talking about the energy we're going to need for the future of AI. The idea of jumping from 3% to, 99% of all power generated? That's almost impossible to wrap your head around. It's a huge warning sign that frames just how critical this whole issue is becoming.
Okay, so let's bring that huge global problem down to a really personal scale. What's the actual cost every time you ask an AI a question? That's the big question we're going to unpack today, and we'll be using data from a fascinating new study to do it.
To really get the cost, first, you've got to understand the tools. The AI world is pretty much dominated by two main types of models, and their differences are absolutely crucial to this whole conversation. So on one side, you've got the heavyweights, large language models, or LLMs. Think of things like GPT-4. These things are trained on just unimaginable amounts of data, and they have billions of what are called parameters, which are kind of like all the little knobs and dials the AI tunes to make decisions. This makes them amazing at really complex, abstract thinking. But all that brain power comes at a huge resource cost. Then, on the other side, you have the more agile contenders, small language models, or SLMs. These are leaner, they're trained on much more specific data, and they're really built for efficiency. The trade-off? Well, they might not be as good at the super difficult tasks, but we're about to see if that's always true.
And this is where we get to the big showdown. See, it's not just about which model sips less power. It's about whether it can still give you the right answer. We have to look at both the cost and the accuracy.
Okay, now this is where the study gets really interesting. This table here compares the power use between the small and the large models for different kinds of tasks. Just look at that difference factor column. For a medium math problem, ChatGPT's big model used 3 times the power of its smaller sibling. And for a hard puzzle, DeepSeek's LLM used over 6 times the power. The energy savings here aren't small, they are massive.
So you're probably looking at that and thinking, well, this is a no-brainer. Just use the smaller, more efficient models, right? But, not so fast. Cheaper isn't always better, especially if the answer you're getting is just plain wrong. Accuracy is everything. And this might be the most surprising find in the whole study. For reading comprehension tasks, ChatGPT's small model wasn't just more energy efficient. It was actually more accurate than the bigger, power-hungry LLM. The SLM got over 91% of the answers right, while the LLM only got 75%. This is a huge deal. It shows that sometimes bigger isn't just more wasteful, it's actually worse at the job.
So let's kind of put this all in context. On the left, you see that graph we just talked about where the leaner, smaller SLM is actually beating the LLM on a reading task. But then look at the right. For really complex, abstract puzzles, the roles are completely reversed. Here, you need the raw power of the LLM to get an accurate answer, even though it's using way more energy. This really illustrates that core trade-off perfectly.
So with this trade-off in mind, what's the solution? Well, the researchers behind the study, they propose a much smarter strategy than just, picking one model and sticking with it.
They call it a dynamic approach. Here's how it works. When your question comes in, the system doesn't just automatically send it to the big, expensive model. No, it starts smart. It sends it to the efficient, low-cost SLM first. Then, if the small model can't handle it, or if the question is flagged as really complex right from the start, only then does it switch over to the powerful LLM. It's all about using the right tool for the job, and that can save incredible amounts of resources on the millions of simple questions we all ask every day.
Now, this dynamic software approach is absolutely brilliant, but it's really only half the battle. To truly cool the future of AI, we also have to look at the hardware, the actual physical data centers that power all of this stuff. Yeah, the problem isn't just about the electricity going in, it's about all the heat that's coming out. The intense processing that AI needs generates a staggering amount of heat, and getting rid of that heat is one of the biggest energy sucks in any data center.
So how do you cool the future of AI? Well, one of the most promising technologies is called liquid immersion cooling. And believe it or not, it's pretty much exactly what it sounds like. Instead of just blowing air across hot computer chips, you literally submerge them directly in a special non-conductive fluid that just pulls the heat away right at the source.
So, how effective is this? Well, according to the industry data, this liquid is up to 1,000 times more effective at getting rid of heat than air is. That's not a small improvement, that's a total game changer for how we manage heat in these massive data centers.
And this incredible efficiency, it leads to a key metric in the industry called Power Usage Effectiveness, or PUE. A perfect score is 1.0, which would mean all the energy is going straight to computing. Well, with liquid immersion cooling, data centers can get a PUE score as low as 1.03. That means only 3% of the energy is being wasted on things like cooling, which is just amazing compared to the 50% or more you see in older data centers.
And the benefits just keep coming. This tech lets you pack servers 10 times more densely. It slashes water consumption. It even makes the hardware last longer because it isn't getting so stressed out by heat. And when you add all of that up, it just massively lowers the overall carbon footprint. It is a win-win-win.
So between smarter software and truly revolutionary hardware, the path to a sustainable AI future is definitely becoming clear. But it does leave us with a really critical question we all have to think about. As AI gets woven deeper and deeper into the fabric of our society, how are we going to choose to balance its incredible world-changing power with its very real impact on our planet?